Alright, welcome back to Meteorology 101. We're just gonna get into the charts, get into the radar. Let's see what we see where we end up here. So right now, southwest Ohio, scattered to broken. Sky is about 5,000 feet. Currently 58 degrees and falling. 49% humidity. That's remaining steady. Pressure is 1,018 millibars. So standard atmospheric pressure is about 1,013.25 millibars, so we're a little bit higher on the pressure. We had frontal passage with all the storms that went through, so now pressure is beginning to rise. High pressure is pushing down out of Canada, so the whole central U.S. should be experiencing a little bit cooler temperatures and higher pressure for the next couple of days, but we will still experience some instability and maybe some upper level disturbances. Let's check out what's going on. We followed the low pressure system stacked all the way up to 30,000 feet on the last video. So that's moved out of the area. We'll just get into the charts and see what's going on there. Real quick, let's pull up the radar, get an idea of what's going on national radar, and pretty much go from there. We'll pull some local radars too if we got some storms out in the areas out throughout the U.S., which we pretty much have rainfall. Get you on the right page here. Alright, national radar loop. Let's go ahead and play the animation. Okay, so pretty much through Iowa, Minnesota, Iowa, all the way. We got a line actually shooting down through Nebraska into Kansas. Looks like thunderstorms in that area. Some convection. Unstable wave or something going through northern Iowa, southern Minnesota, pushing into Wisconsin. And then in the northeast, there's probably that low pressure system that pushed through the area just the last day or so. Just pushing up to the northeast. A little bit of convection associated with that. And then we should have that frontal boundary pretty much right down along the east coast. And I would say maybe a post-frontal trough where this convection is, or just a little bit of weak disturbance there. And then the frontal system should be, let's see where it is, just right along the east coast. And then I would say coming down into the Gulf. So those lines kind of line up and make sense for a low pressure system to the northeast, frontal boundary off the east coast, and then into the Gulf. So we do have some pretty strong convection over the Gulf Coast, right there off Louisiana into the Panhandle of Florida, and a little bit of convection over central Florida, and then just off the east coast. So we'll put up the warnings, see what warnings are out here for any of these storms, if anything severe, if we got any marine warnings for the convection off the coast, and then we'll take a look at that. I don't have the satellite pulled up, so we may go to a satellite if we feel like it. Let's go ahead and see what we got for local radar for now. Alright, so in Florida, we got marine warnings up in the Panhandle, and then a marine warning off the east coast. So we can go and look at observations. I have all the observations posted on the radar. So current obs, we're showing 170 at 9 knots, unrestricted visibility, clear at these locations. So let me get a better radar. We got thunderstorm zone inland right here at, let me get that station popped up. Let me get you a better view on that too. Alright, there we go. Now you should be able to see these pop-ups on these warnings too. Alright, there we go. So we got a special marine warning until 8:30 p.m. Eastern time. Strong thunderstorm located 7 nautical miles south of Maytown or 8 nautical miles west of Mims, moving southeast or moving east at 20 knots. Wind gusts at 40 knots. And small hail. And the source of all this is radar. This is from the National Weather Service in Melbourne, Florida. So if we pull up Melbourne's radar, download a loop there. Now we're updated on the observations in this location. We have thunderstorms reported in that location within that warning area, and then 0.43 inches of hail. And then radar indicated we got thunderstorms reported on the observations. See, this is a thunderstorm broken at 6,000 feet, broken at 7,000 feet. Lightning in the distance northeast and east. And that is in Orlando. And another one at lightning distance, all quadrants. Unrestricted visibility, thunderstorm, broken at 6,000. That's the layer of the cumulonimbus, and broken at 11,000. And let's get a look at that. Occasional lightning, cloud to ground, north to the northeast. Thunderstorm to the northeast, moving east. And cumulonimbus in the distance, southeast to southwest, moving east. Vicinity rain showers to the northeast through the east. Alright, so play that loop. We do a little cross-section on these storms too. Let's see how severe these things are, how far they go up. Just break them down a little bit, and then we'll get into the chart some. We'll go pull up the other warnings too. I'm sure we got some other warnings. Here's the warning window. You can see it there. We got 3 severe thunderstorm warnings, 2 in Kansas, 1 in Nebraska, and then these are the 2 special marine warnings right around Florida. So maybe we'll check out these severe thunderstorms in Kansas. We'll see if we're any threats for tornadoes up in them areas. Alright, let's do a quick cross section on this storm. So we got high reflectivities all the way up to 20,000 feet, and then for the significant 55 dBZs, and then we go all the way up to about 42 dBZs, about 29,000 feet, and then we're pushing all the way up. The overshooting tops up into right around 47,595 feet. So pretty good thunderstorm. Not a lot of tilt to that, just a vertical extent, and then high reflectivities in the mid levels. We can get some hail develop out of that. So depending on the winds and the hail size is what they determine if they go severe or not. We can kind of zoom in on this thing. Let's move it around a little bit, get a better view at it, and looking for any kind of hook echoes or anything. I mean, I don't really see much there. Like I said, this storm was mostly vertical, so we do a quick volume scan over that cell, pull up the 3D model on that, and I mean, we got some pretty good, it's a pretty well developed storm. So let me get this out of the way here. See, all right, so pretty good developed storm. You can see the lighter reflectivities going all the way up to almost 50,000 feet. The significant reflectivities are pushing, like I said, just about above 20,000. So probably 22, 23,000 feet there. When we do the velocity, we can actually pull a velocity 3D scan, and then we can see if there's any red and green. So way up in the upper levels, about 30,000 to 40,000 feet, there is a little bit of rotation there. Maybe right there at about 20,000 feet also. We can see that little pocket there. So definitely a little bit of rotation in that storm. So for a vortex to hit the ground, it would have to be pretty significant. Let's go back to the surface. Let's look at this. Let me get rid of that. Hold on a second. All right, our radar is well to the southeast, so not any really significant counterclockwise rotation. I mean, if you had said that was going out, that's coming in. We got a little cell right there of rotation. Let's go up into a couple layers of elevation here. Let's go back. Now we're on the surface. We're on a lower angle with the radar. I was already up in the upper level, so let's go back. So if we come back to the surface, I mean, we can see some wind shear there. then go up to the in the mid to upper levels, and we got some pretty significant indication of possible rotation there. So get way up in the upper levels, it just disappears. But so I mean, maybe keep an eye on that one. We definitely got hail. That's 0.61 inches of hail. So it's over half an inch. So got to get a little bit bigger than that to be considered severe. Which that warning is gone. So we go back over to this warning. Let's see what we have over here. That warning's still there. We don't know why it wasn't showing. I guess I was zoomed in too far. So that's till 8:30 p.m. So we still got a little while. All right, let's get up to the other radar. Now you get closer to the radar, it really doesn't matter. You got winds coming into the radar, winds going out of the radar, and then a little bit of rotation here off the coast. Going to the upper levels on that. It kind of disappears, and then another whole wider area pops up. Nothing showing up for a tornado watch or anything, so even our convection just isn't there either. Here's got some stuff well to the south. Let's do a volume on that, see if we have anything. And that's pretty weak, so possible, severe weather for the for any ships out there, any boats or ships out in the Gulf. But other than that, maybe, you're always got a possibility of water spout with no friction. Storms to have all the moisture it needs, so anything could pop up on the marine coast anytime. So let's get back to our warnings window. Let's go over here to Kansas. It looks like we just had another one pop up for Kansas also for a severe thunderstorm. Let me move this out of the way. Alright, so we got some pretty high reflectivities at the surface here, so definitely looks like a little bit of hook echoes, and then within this storm. So we could start getting into the tornado threats right here. So let's do a cross section right here real quick. So you can see the tilt of that storm and the high reflectivity is going almost to 20,000 feet. So we're not quite there yet, but this thing is starting to build up pretty good. If you start seeing these purples way up in the upper levels, that means you got a real high reflectivity. And that could be a pretty good size hail in those upper levels. So let's just break down these cells a little bit. We had that hail reading right there, about 0.67 inches. So this still just over half an inch. Here's 1.03 inches of hail. So like we were saying before, there's some overhang right there where the hail's falling through. There's the cell, and then the updraft comes up. So we probably have a tilt on the updraft, and then pushing the hail up, and then when the hail gets too heavy, it falls down, and that falls down into an opening that's not showing up on the surface of this radar. So if you go into the upper levels, now you can see there's reflectivities shooting up over where that hail area is. So we're getting that, like I said, the reflectivity start on the surface, move over, so you do have tilt on that storm, you can tell. And then if we do a cross section right there, right across that, now you can see that tilt. So now there's your overhang, and then you'd have the hail at the surface right below that. So, and then you don't see any major reflectivity at the lower levels. All of it's over there to the west. All right, so if we do a volume scan on that, now you can see a pretty well developed storm pushing up into the upper levels. So I don't see any major, like a vortex or anything in that, but that's a pretty good volume scan for, high reflectivities well up to over 20,000 feet. So, and then you got your 60 dBz or higher in the lower levels. So it's a pretty well developed storm right there. Go down to the south a little bit more on that storm. We like to look at the southwest quadrant of that storm, of those storm cells. That's where you're going to get that hook echo, and you're going to get the development a little bit better chances for tornadoes in those areas. So Looks like this one's kind of broke down right between the center of those cells. Sometimes when I do these scans, the radar on the surface is more updated than the composite, so I don't get a very good hit on that cell. So I gotta move over a little bit. This one, we're still pushing over 50 dBZs at 10,000 feet, so we're still going severe. But if you look at, let's do a quick cross section right here. Try not to move too fast here, but do a cross section. Now you can see we got the tilt of the storm, but when we start getting those 50 dBZs in those upper levels, then you want to see pretty strong areas of those higher reflectivities in those upper levels, and then we can get you can start looking for tornado development. So right now we're just in the severe stages. So here's 1-inch hail. That's a severe criteria, and 58 mile per hour winds is the other. And then let me get rid of that real quick. Let's do a cross section here. And then any rotation indicated by radar automatically goes to pretty much a tornado warning. Now, if these were to develop anymore, it's getting a little bit late in the day, but for the sun, to give it a little bit more heating for a little bit more energy, it might need to become a tornado. But if there's any threats that show that this could possibly become a tornado, there should be a tornado watch out. But unfortunately, I'm not seeing any watches, and I don't know if there are any watches in those areas. But once you hit the severe part of these storms, you start getting these little areas of rotation around, just like these hook echoes starting to pop up along these lines. Then it's possibly just to go to a severe or a tornado warning or tornado watch instead of a warning. But I don't know. I don't see too many tornado watches anymore. All of a sudden, you'll just see a tornado warning pop up just all of a sudden, and people don't get those. They don't get to watch like they used to. So, all right, we'll get out of this for a second. Let's get over to the charts. Let's see what's going on there. Back to the radar. Let's go. Pull up the surface chart. All right, we got high pressure over Missouri. So we had most of our severe weather in Kansas, Nebraska area. So you can see the troughing in that area. We got ridging up from the high, and then we have possibly an upper level low with a pretty pronounced surface trough that be causing the instability right there through Nebraska and Kansas to cause that severe weather. There's a low pressure system moved off the coast right there over Connecticut, and then you can see the troughing into that out of that low with the frontal boundary possibly pushing right along the east coast, and then with the thermal advection pretty much becoming maybe stationary right along the Gulf Coast, and then that would cause any of that lift it would need for that instability right there. And then you see the trough off the east side of Florida causes that instability for that marine warning. So all of our warnings are in the areas of the most instability where we have the troughing and little bit of thermal advection right around that area. Maybe just a frontal boundary causing the lift. So let's go to I'm going to erase this real quick, and we're going to pull up our surface plots. It looks like our clouds in our cloud cam there, we pretty much most of that stuff went away. I'm just looking at a clear area, and there's still some out there, so we're more scattered than we are broken now. So we're starting to clear up a little bit in Ohio, southwest Ohio. All right, so right along the mountain area, and then eastern Tennessee, we got marginal VFR conditions. We got ceilings right around anywhere from 1,000 to 3,000 feet, more visibility, 3 to 5 miles. So if we look at these readings here, we have There's a C24, so we're at 2,400 feet on the ceiling. So we're less than 3,000 feet. That puts us in that blue. And the ceiling 1,800 feet. So we're that puts us right there in the blue on that one too. All right, so let me get to a drawing tool here. Alright, my pen. Alright, let's see what we got here. So, looking for the frontal boundary. We know that low was off the just over Connecticut. Let me get my stuff adjusted here. Alright, now we're gonna go low pressure. Alright, now our frontal boundary we said was pretty much right along the East Coast, but we gotta verify that. There's a temperature of 86. There's one of 68. Alright, so if we had to say our frontal boundary, we have to go right through that trough. We have our wind shift. So let's look at we have our temperature difference. Dew point is 60. The dew point's missing on that one. There's a buoy out there. But if we look at the winds out of the west and then going southwest, we have a little bit of shift right there. Not much of a shift here. Right here we have a kind of a northwesterly flow. And then we're going up southwesterly flow. So we're almost putting that front pretty much right through there. And that's pointing right there at where that marine warning was off the coast of Florida. So, and then our winds are shifting from the south. And then we got one over here in the Gulf from the northeast. So if we had to bring our frontal boundary back around, we have to bring it around that way. Alright, so look, it's a little cluttered. Let's go. Wind shift. Not shifting much there. I'd like to see more of a north westerly flow. But we're going westerly, so that's pretty good. Here's northwesterly right there, some troughing. Then we got this northwesterly right there. There's some troughing, so maybe we're pushing back a little bit further, and then maybe just have a maybe a prefrontal trough right through there. A little bit of troughing there. There's our flow right there. So, but we do have that mountain range right there too, so that could always cause a little bit of wind shift. You have a little bit of different winds on the lee side of the mountains and windward side of the mountains, so that could happen too. So we got 77, 68. We got a temperature difference right there. 75. Can't really read that one. There's a 79, 79, 77, 74. 78. We're not changing much in this area. We're staying pretty warm. So 60. So I think it's a 75 right there. And 77, 67. 77 and 67. That's a difference. But like I said, there's a, with the upper elevations kind of separating that. Got to keep an eye on that too. But anyway, low pressure. We got IFR conditions is basically the ceiling is less than 1,000 feet or less than 1 mile visibility. So we got mist with the two little lines there for weather indication, and then this is looks like rain and or maybe drizzle, and then there's some light rain, light rain, light rain. Overcast skies, cloudy all through here. So if we looked at satellite, we'd have pretty much clouds all through this area. Alright, so let's go ahead and pull up the let's let the computer analyze this thing. I like to do my own analysis first just to verify. Sometimes I'll throw the computer stuff up there and then re-verify where the computer's gone wrong. Because if you place the center of that low, you want to prove it. We've placed the low there. Let me go. We got the low. Now what's proving that low? We gotta have rotation around that low. So around the low is counterclockwise rotation. I don't really see a wind barb on that one. I see a flow there, flow there. So winds are going to be counterclockwise and into the low. See how that's going into that low. So we're still rotating there. We've got a flow there. So we could almost put it right there. And then I'd like to see an easterly flow. There's one right there. Alright, so pretty much right there. That's pretty close. I'd call that low pretty accurate. And then, like I said, with that frontal boundary, we can go set up the isotherms. Here's another way we can look at the that frontal boundary too, with the see where all our thermal advection is. All right, here we go. So there's the low. Now, let me get the drawing tool on. All right, here's the low. Now look at, here are the isotherms. Not much advection going on there within that low, but we said we had that rotation right there. Alright, so, and then we go, if we had to bring a cold front out, we could almost, this might be even an occluded low, but it's a little hard to tell. We'd like to see a little bit more thermal ridging up into the center of that low, but with the cold front, so here's a shift. So we had to bring a cold front out of the center of that low down through this troughing. There's some shift right there. That'll bring it even further to the west, but we're getting into that mountain range, so that could be separating that too. And then you want to look for the temperatures, but the thermal advection, let's go with let's see what we got here. Where there's isotherms cross the isobars, lines of equal pressure, lines of equal temperature, both cross, then we got advection. So there's our cold air that's being advected from the northwest. So we can always place our front right here. So the leading edge of that cold air advection is the cold front, and then we go out of that low, and then we'd have to go pretty much off the chart, but pretty much pushing. You get that easterly flow right there. So that's a indication that your warm front is the south of that, and then your winds out of the south pushing that warm air up. Now you have warm air advection all through here. So the leading edge of that warm air advection is where the warm front is. So there's the warm front. There's the cold front. Pretty close to being into that trough. And then maybe a, like I said, with this rotation right there, that little bit of troughing, maybe a prefrontal trough. Alright, so that's pretty much it for the analyzation on this thing. We do have this high and we got this low, so we got like a unstable area right here that's causing all this convection over Kansas and Nebraska. So we got dew points 44, 46, 39, 33. That's getting pretty low. We want to see like almost 60 to get really into the severe weather where you're going to get tornadoes and stuff. So we are in severe thunderstorms, but we're not quite there for the tornadoes yet. Here's one 678 over that coast, off the Gulf Coast, and then 72 right there for a dew point. So we can get severe weather, down in these areas and possible tornadoes or water spouts since they're over the ocean. Alright, let's go see what this computer has for fronts. Now this gets pretty nasty sometimes, so I'm going to go ahead and do another analysis on pressure without the highs and lows. Okay, and then let me go with the isotherms. Let me go station plots. And then we'll let the computer place the fronts and the highs and lows based off of that download and see where we go. Like I said, they can get pretty nasty on here, so that's why I like to do my own analysis on that. Alright, so get back in here if we go. Alright, they got that occluded low well to the north. And then they got an occlusion going into another low. Then your warm front, which we said that warm front was pretty accurate. I'd probably bring it out a little bit further to the north. Let me get rid of this. Put the proper color in here. So if we do out of that low for our triple point, that's not really, we'd say, okay, that's our triple point, not really a low. But if we're going to have our low up here, then we have to go with the occlusion, and then we go with the warm front, and then we go with the cold front. So you can't prove a low here. There's no easterly flow, nothing rotating around that low. Now you can have just a light trough off that low, off of that frontal system, but cold air advection, I mean, we don't even have the cold air advection all the way down through that area. So this is pushing it. All right, so if anything, let's go back here. We got pushed it back right along the mountain range for our wind shift, so brought our cold front further west, which that's okay. And then once you get out of these isobars and you have really no thermal advection, you don't have cold air advection. I mean, you got winds out of the north, but look at your speeds. You got 5 knots right there. So there's 10, there's a 5, there's a 5. So you're not pushing a lot of cold air to the south. You know, the wind does blow out of a high, but it's not that's not enough to really justify a cold front through here. If anything, you go cold front, go to become stationary. Just put it a stationary front right through there until you get into your other isobars. Now there's another troughing area, so it's more or less ridging because that's coming out of that high. So you'd be ridging, and then so you're not going to put a front into a ridge. You're going to wrap that front around the ridge, so around that high pressure, that cold air advection. Really no cold air advection there either. I mean, you got a 10 knot wind, now 5 knot, and then you're shifting from the south, so you do have some sort of boundary here. So it's possibly that ridge push it through right there, and then right here's rotation, ridging, ridging. Ridging. You can see your flow there. So now you got your ridging. Is pretty accurate there. Stationary, I'd go stationary here. I'd say, okay, let's go with the front right there. That's fine. Go occluded. The cold air is caught up with the warm air. It's overriding, pushing over top of that. And then, so you have warm air advection in the upper levels, cold air advection kind of behind that. And then, so now you got your occlusion. Then you got your triple point. I wouldn't really put a low right there, but call that a triple point, and then I would bring my warm front a little bit further to the north because of that easterly flow right there. So that's going to place your warm front further north. I mean, the idea being correct with this stuff is the difference between doing a correct forecast for this area or not. If you where the placement of that front is, if you bring it down here, versus here or up further to the north, approaching Maine, if you're in Maine writing a forecast, then you need to know how close that warm front is to your area. So you can see if you got what your wind speeds are, what your thermal advection is, and when when to forecast these low ceilings. So when you get into those red IFR conditions, you want to know when those conditions are going to start, where that front is, how close it is, how fast it's moving, and when it gets into your area, you got the overrun that is going to cause those low ceilings. So if you're forecasting for any aircraft, you need to know the details all the way down to that level. Now, if you're just on the TV and you're just whatever, it's like, okay, they don't really, forecast ceilings. They'll forecast, broken, cloudy skies, partly cloudy, mostly cloudy, all that. But they're not going to tell you if that's going to be less than 1,000 feet. They don't really care. I mean, because the general public really doesn't care. You get into your airports, and then that's where they care what the ceilings are, what the visibility is, so they know if they could take off land. So if you're flying a drone, now you're getting into a lot of weather. You're going to have to learn a lot of this weather. Now you don't have to learn how to forecast. You're going to have to learn how to read a METAR or a TAF to find out what time of day you're going to be allowed to fly or not, because you have to stay 400 feet below the clouds. Well, if your clouds are 400 feet, you're less than 1,000 feet. You want to know how high you can fly that drone. The max height on a drone is 400 feet above ground level. So if the ceilings are already below 1,000, then you need to know what level they are, so you know how high you can fly that drone. Same thing with visibility. You're not allowed flying. You have less than 3 miles visibility. So basically, you're almost, if you're in IFR conditions, you got flight restrictions on a drone too. So, and plus you got to get a license to fly a drone commercially, as far as if you were making any money on that drone. If anybody watches this channel or begins to watch this channel, if you fly a drone, you want to do some drone forecasting, pull up how to read those METARs, TAFs, and then get into that pilot thing. I do have on my website, I got a whole thing for drone, the FAA Part 107 testing, practice testing, some questions on there, so you can just test yourself, and then go through several articles on the rules and laws of flying drones in what conditions you're allowed to fly. So if you want to go check that out, I'll put a link in the description for that one. Alright, so there's our surface chart. Now we got the high pressure troughing. This is showing a cold front, actually, to the west. I'd say it's more of a trough more than it is a cold front. I mean, you got some wind shifts. Don't really see the isobars and the isotherms crossing enough to say, hey, there's some major thermal advection to be a cold front right there. Now that high pressure system could be ridging down further. But if we look at it, let's go look. Our winds are kind of all over the place here. So if we start looking into that, there's some rotation. There's out of the north, out of the west, out of the south, out of the north. I mean, like I said, our winds are pretty much all over. We do have ridging, troughing. Let's see, as far as frontal boundaries. I mean, there's some troughing. There's definitely some boundaries in there separating these wind directions. But if you're doing that, you're going ridging there. I mean, typically, if you got a warm front, say like this, well, that's more stationary. So they're going blue, red, blue. So they're going stationary through there, whatever that is. That makes no sense with that low there. Cold front out of that low, going back into the stationary. Warm front. I would say troughing, ridging. If you put the ridging, troughing right there with that, where that low is, ridging down through here, then troughing, then ridging. Now you can just see you got, stable, unstable, stable. So in your unstable area at and ahead of that trough is where you are going to get your convection. So that's Nebraska, Kansas. So we're right there. Then you get into the micro forecasting, get down into them lower levels and find out where you're at on the radar and where there's major instability, moisture, instability, and lift, is the 3 ingredients for a thunderstorm, and you get into that in that area, it's a good place to start. So anywhere along those frontal boundaries, that's your lift. The frontal boundaries are the troughing, that is your instability and your lift. So that's what you need for your thunderstorm. All right. So if we take us up one level, go to the 850. All right, so what we got here. All right, so moisture levels. Moisture at 5,000 feet. Contours. Upper level trough. Pretty significant thermal advection. Pretty much what we were dealing with yesterday on the live stream. We pretty much, not much has changed, just moved to the east. So let's go to pretty much moisture. Anywhere you see those black filled in station plots, that is significant cloud cover, moisture. Dew point depressions of 5 or less. We covered that yesterday. So if we go to our low, I don't have any data up here. So we had that occluded low on the surface, but okay, let's call the low right there. Let's go thermal advection. We're going to have to look for a wind shift. We're going to have to look for temperatures. There's an 11. There's a 5. Let's see what we got here. First, scribbled right over it. Okay, so that's for the west, south, southwest, west. And we're kind of going westerly all through here. So we had that occlusion, and then got our wind shift. Bring our front, maybe an upper front a little bit further west, right along there. So if we had our cold front there, we're coming pretty much with that low pressure system to the north. If we had the low up here, we stack back on that, but our fronts are catching up. The upper front's catching up with the surface front, and that's becoming a little bit more vertically stacked. So we're getting a little bit of weaker lift in this area. So that's why you're not seeing so much convection, in this area. You got that little bit along the coast of Florida, along the Gulf Coast, and then we have that disturbance over, let's see here, over Nebraska and Kansas. So if you said the trough was still right there, you got an upper trough supporting that. And then, there's really no isobars or contours in this area to really support much advection. So, and then even the lack of moisture, in the upper levels. This could be a little bit older data, but right there in Nebraska, we have that significant moisture. Then we got way over to the east in Iowa, so we're not really showing a lot of moisture there. We got we still got the instability. Looks like that contour is going like that. So we have that little bit of instability right there to give an upper trough of 5,000 feet to create, bring that lift up to basically help that moisture that's at the surface come up and meet the level of free convection. And once it hits that, then it can just go on up to 20,000 feet or so. So we have to go up to another level here and see what features we have, if any other support further up, but not a whole lot of support right there for tornadoes. We can look at stability charts too. Let's go pull a stability chart and see what we got, because we didn't get to that yesterday. pull. Let me get to the right level. I'm going to go up to, right now I'm going to go up, let's see, let's go back to the surface. Pull stability. Here's the lapse rates. Lapse rate's really going to show you too is anywhere there's a chance for tornadoes, you get a steep lapse rate. So right here's a 7. Well, I'm actually moving the screen. I was trying to draw on it, so give me just a second. Get back to my drawing mode. Alright, so there's a 7. That's where once you hit 7 degrees per 1,000 meters, temperature drop, going into the upper levels. If your lapse rate steep, once you get the average lapse rate is like 6.5 degrees Celsius per 1,000 feet. So 1,000 meters. If you get up to 7, you start getting a steeper lapse rate. Temperature cools the atmosphere is cooling faster than average in the upper levels. As it goes up in elevation, then you get a lot better chance of instability. So over the 4 corners is pretty much where that instability indice lies for that chart. So we don't have that over Nebraska or anything. So we don't have much. That's not a good indicator for Nebraska being possible tornadoes. Let's go to pull up precipitable water. That's going to give us if we get some rain, how much is it going to rain? It's good. This is good for snowfall. If how much precip you can get, and then 10-to-1 on the rain snow ratio, and then you can calculate this to how many inches of snow. I mean, this doesn't do too bad. So 0.8 inches, 0.7. Actually, let me get start drawing here again. So 0.6, 0.7. You got a half an inch of rain, just over half an inch in those areas. So you look right there through Nebraska, Kansas area. That's where you start getting into the 0.6. Further south you go, the more precipitable water because of the more moisture off the Gulf and over the Atlantic. Alright, so let me go erase that real quick. And let's do another one. This is an instability chart. Let's just see what our instability indices are here. So pretty much everything to the south. Anywhere there's a major chance of thunderstorms, it looks like your biggest chances are, pretty much for tornadoes and stuff. It's pretty much over the Gulf, out in the Atlantic. Let's get rid of that one and go to one more. For instability, let's go. I got 2 of these charts. One's a little more intense than the other. It's an advection chart that shows where it's basically like the SPC puts out for their instability ratings for tornadoes, thunderstorms, where their chances are. So if I pulled up SPC's website, they'd probably be pretty close to this for where the enhanced chances of severe weather is going to be. So it's off the East Coast and then right down there off Florida. So this is pretty accurate for that East Coast special marine warning right there off the East Coast of Florida. So that hit that pretty good. Now I didn't really see much convection. We have to go back over to I didn't see any warnings out there, but go off the East Coast of North Carolina and see what we have out here, because this looks like a pretty good chance of severe weather out there also. Alright, let's go. We'll do one more to the one chart just like this, but a little bit more intense. It'd probably throw some more stuff. I mean, if you look at this is a 0, but it's still got that area up there through Nebraska and Kansas. So I want to see if something comes up on the next chart for if I run this thing on a more intense level. Alright, get rid of that. Let's see. Alright, right there it is. That's where it landed, so that's pretty good. Now over Mexico and western Texas and southern New Mexico, there's a just as much chance too. So pretty much landed all the way off the East Coast. Like I said, this is a way more intense one. Now, if you look at the darker reds, I mean, this did nail it right there on that coast, right there off the east coast of Florida. And then let's go back to the radar and see what's off the coast of Virginia and North Carolina. But we did have there's severe storms right there, and we'll have to go down to New Mexico and see what we have down there. So actually, this thing popped up pretty accurate. So all right, let's see what we're gonna pull up some models too. I'm gonna do let's go to that radar real quick. See what we got here. Alright, so this is Oklahoma, Kansas. Go up into Nebraska. Download these loops. Alright, so we're not having much there. We got a little bit of few isolated cells there, but nothing severe. Our warnings are still down here in Kansas and in Oklahoma. So, and then we still have the ones off the coast of Florida. So there's nothing else severe out there, but let's go follow a couple radar shots over. I want to get down here into New Mexico. Let's get an idea down there on that chart and see what kind of instability there was any. Just because there's no severe warnings doesn't mean there's no convection down there. Alright, so we're down here in southern New Mexico and western Texas. I don't see anything. I see a couple little lines here. Nothing, no convection though. Let's get this radar. Alright, nothing really there either. Make sure I got the loop downloaded. We got, what are we reporting? 2504 knots, unrestricted visibility, and clear. So all these are clear skies all down in there. So we didn't get any, I guess we just didn't have the ingredients present to cause any thunderstorms in that area. So let's follow these over. Actually, let's just go back to our warnings window and go to the East Coast. Should be able to pop us up over there. Alright, we got U.S. Space Force Network Tower 211 measured a thunderstorm gust out of 280 at 42 knots. So there's the Space Force at work. Alright, I want to go to the north. I want to go, we got to follow these radars up. We can't just go over there. I can type one in, but I don't know. I got KMHX is North Carolina. That's the only one I really know over there. That's where I worked for a couple years forecasting right there in Cherry Point. Alright, so we do have some convection right here. Nothing severe. Here's the Raleigh, Durham, North Carolina radar. Let's get a loop on that. No warnings, just some isolated cells. And what do we got here? Heavy rain. Current weather, 2.5 miles visibility. West-northwest on the winds at 6 miles per hour. And we just do a quick cross section. Let's just see how high this thing's going. Pretty much nowhere. You got, I mean, you're pushing right there at the limit of possibility of being severe. 50 dBz at 10,000 feet. I mean, you're right there at that threshold. I mean, you could be, say, hey, well, this stuff gets any worse, you start seeing any more indication on radar, possibly putting out a severe warning. But I don't see any hail indicated by radar or anything like that. So, there's really nothing to worry about on that storm. Plus, the getting later in the day like this, the sun goes down, all this stuff pretty much weaken, and won't be much of a chance for any kind of hail or anything like that. So, two criteria to make it severe is the 1-inch hail or the 58 mile per hour wind gust. So, the one thing anything would make this severe is if this collapsed and caused an outflow boundary of gusting to 58 knots, but that's probably not going to happen here. You just, once that starts to collapse, or you get rain, you get a downdraft, and you get the outflow boundaries, then you can get just some cooler winds from the upper levels. The cold air drops from the upper levels and blows out once it hits the surface. It'll cool the temperatures off a little bit, but getting up to the 58 mile per hour range, pretty much slim to none. But it does have tilt on the storm. It is 50 dBz over 10,000 feet, so you could, that could possibly develop to a severe thunderstorm, but not really likely at this time of day. So you get into the daytime heating, do that before 4 o'clock, and then definitely be keeping an eye on that one for a severe storm. All right, so actually, I don't get a cross section. I want to do a. You can just take this thing into the 3D. You can see it right there. It's pretty cool, but it's not nothing to be a major threat. All right. So let me see. All right, let's go. All right, we covered the charts. We covered the radar. Let's cover the models real quick. See what we have here. We got a pivotal weather. Weather is one side we could pull scooties and stuff, and we can see what temperatures are pretty much forecast going to be on the surface with the high pressure system as it pushes to the south. So if you look at right there in Nebraska where the high pressure is right there, and then we have that leading edge of that high, they were saying pretty much a cold front. So a little bit colder temperatures back behind that high, but I wouldn't really necessarily say a cold front, because I don't see the low. Here's your low pressure. If you had a low to the north and a cold front wrapping around that high, then I could say, okay, we got a frontal boundary. But I mean, okay, if you had any kind of boundary, it'd be like a weak boundary, but you don't really have the thermal advection associated with that to justify a cold front. As we progress, now we could get a low pressure system popping up and then showing the front of that boundary. So let's see how we go on that. There's a low right there. So right there over Iowa. And then you could go maybe pulling out of that trough, wrapping around that high with thermal advection, because you can see this thermal advection here. Winds out of the north, cold air advection. That's actually the heights of the 500 millibars, so it's really not thermal, but it's being the heights of the 500. As you get that, your thermal advection is going to affect the heights too. So just kind of an indicator there. This ribbon right here, that the height ribbon of 500 millibars here, that would pretty much be the placement of a jet stream. So that would be one indicator right there. Let's go to high pressure pushing all the way down, all the way into Missouri. Let's go click on this real quick. Let's see what we got for a temperature. We got 41 degrees all the way down to Missouri for the forecast surface temperature. That's all the way into southern Missouri, even into northern Arkansas. Let me get back to where we were. And then forward, continue forward. All right, now it's a low pressure system off the East Coast. It's just kind of, it's like a low pops up right over North Carolina, drops to the South Carolina, then off the East Coast, and then comes back and just kind of becomes more well developed over over North Carolina, and then just continues to push off. But there's this high pressure. This thing's dropping all the way down into all the way to the Gulf, ridging all the way to the Gulf. So we got cold air advection just from that center of that high, chilly air. It's not gonna be freezing or anything, but we got our temperatures are definitely going to cool off. Now we got a low pressure system developing over Colorado, Wyoming, pushing south, and then on the lee side of the mountains we got quite a bit of convection over Nebraska again, and then this low pressure system pushing to the east. Looks like we got some thunderstorms coming through Ohio, southeast Ohio. So if any of that becomes severe, then this is going to be on Sunday, 15Z. It's about 10 a.m. on the 9th. So I guess that's Mother's Day. Alright, I gotta find out what time we're doing the Mother's Day thing. See if I can get out there and start chasing after some of that. I'll stay local so I can talk to Mom on the phone. Alright, so low pressure system pushing to the east. Continues east over northern Virginia, and then straight off the East Coast. Our steering flow is just almost directly east. Alright, convection down into Texas. Now, when you get down into Texas, Oklahoma, get into Tornado Alley there, then you get any convection. That's where you really got to watch it, and especially with any daytime heating. This is overnight and early in the morning, so really not a lot going on there. It's probably why most of that dies off. But it looks like we got cold temperatures pushing over Colorado, and actually some snowfall possibly in Colorado. Then we got our development down over eastern Texas again, and then into parts of Mississippi, Alabama, and then that system pushing to the east, and then we're pretty much maintaining our general path of severe storms, flash flooding, all that right through those Gulf states. So they've been just getting hammered this year, so that ground is plenty wet down there. So southern Texas looks like possibly get a little bit of cells there, and that pushes down into Mexico. But this other system, the unstable wave, just pushing through, and that's going through Kentucky, and then becomes a low pressure system right over the Ohio Valley, and then that pushes up kind of to the northeast and to the east there once it gets on the other side of the mountains. We'll have to keep an eye on that one too, see how much convection actually develops out of that. These models are hit or miss on this stuff, so always a chance of severe weather popping up in toward the center of that low, or to the north of that low, right around that wraparound. So getting to an occluded low, if it gets deep enough, we can become pretty unstable and get some pretty good heavy stuff on the north side of that low, just like the one we're looking at right now over Wyoming, coming out of Wyoming to the north of that. Pretty heavy convection. Then we just got scattered stuff all the way through, right down through the central U.S., and then Oklahoma, small area in the center of that, low pressure system. Get out of here. Try to get that thing out of the way. There's a pop-up. Well, you can't see it anyway. All right, so Montana. Yeah, now I just messed up. Now I just really messed up. Let's go. Where were we? We're pushing through the north there. We're almost done with this with this model run. Alright, so North Dakota. Let's go back a little bit. Montana. This looks like some heavy snow in southern Montana. And then along with we'll get some thunder snow right there. Some convection and snow showers. And then that low pressure just pushing up to the north right through North Dakota. Alright, so then a big line, pretty heavy line of convection. looks like a low pops up over eastern New Mexico, over the panhandle of Texas. And then that line of convection popping up over Oklahoma through Missouri. But that's some pretty heavy stuff. That could be the next level of severe. And we got, actually clicked on that, we got pretty heavy moisture all the way to the upper levels and a pretty steep lapse rate. So when we're looking for that, we're looking at a pretty good possibility of those storms. All right, so let's go. I think I went way too far. All right, so there's the line. Oklahoma right through Tornado Alley, Oklahoma and Kansas. Getting pretty heavy in Missouri through St. Louis. And over there in Ditmer, small town, I guess, and pushing up into the Ohio Valley, and then over the Great Lakes region with that low pressure system. And then this is pretty much where the models end, and still in North Dakota and Montana. Got some wraparound on the top of that northern part of that low pressure system, and getting some convection there. All right, so that's pretty much it for the model run. Let's go. One more. All right, let's see what we got. All right, Tropical Tidbits, GFS, model run. We'll go through this one real quick and then we're going to end it. It's all, both of these pivotal weather and Tropical Tidbits GFS models. I'm not much of a models forecaster. I was pretty much, if I use the models, I use text models because I want to see what the height of the clouds are. And I got more use for height of the clouds, wind direction, speeds, and stuff like that than I do just saying, hey, it's going to rain. Rain and then thunderstorms in these areas. I mean, that's good to know. But when you're pinpoint for one location, you want to chase storms or something like that, then you need to be way more accurate than, just what these models are putting out. And pulling those SCOOTs on the pivotal weather, that's a huge advantage on that forecast data because you can actually see your lapse rates and see your moisture levels all the way up into the upper levels, and that gives you a pretty good indication of where the most severe weather is going to occur. Alright, so like I said, we're just going to go through this one pretty quick and then pretty much call it quits. So this one is, I think they're doing a model run now. Let's see if it may go out to. It may go out a lot further than the pivotal weather did, but let's get an eye on it. High pressure pushing to the south, low pressure pushing off the east coast, and then out to sea. Wrapping back around, coming into Maine. You get that wraparound moisture into Maine, so you can get a pretty good weather up in there. And then you got the central, eastern Kentucky, Tennessee, and then through Missouri, you got a unstable wave, and then low pressure over Colorado, coming out of Colorado, and then most of the convection to the north. And then a pretty good line of convection there, and then pushing into Ohio, and then we have that little bit of convection in southwest Ohio, so we keep an eye on that thing. And that's actually on the 9th, that is 18Z. So it's about 1 o'clock. So it looks like we're going to get rain most of the day Sunday, Mother's Day, and see if I'm staying home or not. We get a convection in the south over northern Louisiana. This model is actually showing quite a bit of different run than the pivotal weather did. So we got that convection popped up and then it just kind of goes away. But then pretty much Alabama, Mississippi, Georgia, pushing some convection down into Texas, Dallas, Fort Worth area, maybe south of that, and then through central Texas. High pressure well to the north, pushing south. Large area of rain, convection through the south central U.S. Then we go pretty much strong convection eastern Texas. That would be right there is Wednesday, 12Z. It's like 8 a.m., 7 a.m. Central Time. That would be May 12th on a Wednesday. So May 12th on a Wednesday, possible severe weather in eastern Texas, Louisiana, over Louisiana and Arkansas. And pretty much our Gulf states just getting hit again right there. So then a low pressure pops up out of that over the Ohio Valley. Looks like not much convection, just a low pressure system, and then maybe that frontal boundary ahead of that high, and then the convection off the east coast. Pretty much North Carolina getting hit pretty good on the convection side. Have to keep an eye on that one too. And then, like I said, we got the low pressure to the north that's pushing straight up into Canada, and then we get the line of convection back down through the Central Plains into Iowa, Missouri, Kansas, Oklahoma. Pretty much all the same. What we see in there now, heavy area of convection, Missouri, back into Kansas. This is on May 20th. So this model run is going out pretty far. Yeah, that's pretty much it right there. We got a, what is this thing? 384 hour run. So that's pretty far out. It's a couple weeks. We got May 21st. So, alright, convection right there in Missouri, Kansas for the May 20th. Convection eastern Texas, Louisiana a little bit, and then pretty much right there in Tornado Alley on Oklahoma, northeast Texas. That's Monday, May 17th. We'll keep an eye on that one. And then a whole line of convection through Tornado Alley right there, all the way from Oklahoma all the way up to Illinois, western Illinois. We got 12Z on Sunday the 16th. So that's over a week out. Low pressure system over the east coast is pushing to the north, and then it looks like New Jersey, Connecticut, getting pretty heavy convection over there and hit pretty hard. So one part these models have been missing quite a bit here is the severe weather over off the east coast, the east side of the Appalachians. They've just been like severe storms popping up, tornado warnings popping up, North Carolina, Virginia, and just popping up out of nowhere, and nobody, not really talking about that. Everybody's looking at Tornado Alley this time of year, but we got pretty good convection over eastern North Carolina, and definitely that gets over that warm Gulf water, and we can get some pretty severe stuff over there. So we need to keep an eye on that. All right, I'm going backwards now instead of forward. So Oklahoma, eastern Texas, that's northern Louisiana. Like I said, the Gulf states right through that time frame, and that is May 12th, 18Z, 12 to 18Z. And right around noon or so, pushing through the Gulf states, snow in Colorado, and then we got convection back here into Mississippi on May 10th. That's overnight. Overnight on the 10th, Arkansas, Louisiana, Mississippi area. Low pressure developing and pushing into Indiana and then over the Ohio Valley, and that looks like another frontal passage as high pressure drops back down out of Canada. And let's see, where are we on? It drops to the east, pretty much the northeast coast, that high pressure does. So, let's see, we don't have scooties on this for that to see what our temperatures are, see where let's see what our temperatures are going to be at that time frame. As a high pressure comes out of Canada, if we're going to keep us mild for a little bit longer instead of jumping up right in the summer and getting pretty nasty, humid, and being one of those nasty, dragging, humid summers. I don't think it's going to be that though. I think we're going to be cool air out of Canada, pushing to the south, then to the central U.S. just keeps dropping down, pushing to the east, and then tight pressure gradients, and I think we're going to have a pretty active, severe weather year and windy year. I think it's going to be, our pressure gradients are going to tighten up. I think we're going to be windy. I mean, look at these pressure gradients right here. Look at the pressure gradients over Oklahoma, Kansas right there. I mean, most of these models are not real accurate on that stuff, but with the high pressures pushing down out of Canada, you get that cold air pushing into the warm air and starts pressing into that subtropical high and pushing into each other, and you get the tighter gradients. You get the winds out of the south and the winds out of the north as there's high pressure pushed through. Then you definitely get that there's tighter pressure gradients causing windier conditions. So definitely keep an eye on that for this summer. All right, so I think that's pretty much it. Mostly, let's see, maybe scattered, a little bit of just some cumulus outside here, and then maybe a little bit of stratocube, just pretty much dissipating on the outside on the cloud cam there, and most of that stuff you can't even see. You see one little cloud to the south. Those just the bottom of that screen there. It was a little bit above that, a little bit to the right of that, and like I said, it's like lightly scattered. Most of the clouds are dissipating in southwest Ohio. So thanks again for tuning in, and I'll leave a link in the description for the charts and for the drone links for that drone category. So if you want to get into flying the drones and see what the rules are, and I got quite a few articles and some practice tests for that certification on my website, Meteorology101.com. Like I said, I'll put a link in the description to the drones, to the charts, and I'll update the charts tonight. And then you can keep up with us. Let's keep us coming. What we'll do is here in a few days or starting next week, I want to try to get some educational videos out. I know I've been saying that. I'm waiting on some more equipment to be more prepared for that. As soon as that stuff shows up, then I get hooked up, and then we can get some whiteboard explanation videos out as far as explaining how these systems work, pull up the weather charts, identify them on the charts, draw them out, and do the explanations, break them down, do some definitions, do some 60-second videos on definitions, weather systems, low pressure systems, highs, semi-permanent highs, and just your quick 60-second description on something. So, hey, we learn something every day, then we get better at doing this job. All right, thanks for watching. Visit Meteorology101.com. Hit the thumbs up. Help me out on the channel. And